Hey y'all, Mr. Kyle, Myers Mathematics, and let's just jump right back into it here. So this is part one of why Cramer's rule stinks. And it does. It smells terrible. And here's why. There's so many different ways you can solve this system that are way easier. I mean, you can do elimination method. You could do substitution method. You could graph them. You could put them in a matrix in your calculator and make your calculator solve the matrix. I mean, if you're doing that by hand, you're getting close to smelly. But this is like beyond smelly. This is like something like got left out, and then it started to grow mold, and then after that it like kept going, and then it's like you open up the lid, and you just take a big whiff, and that's what's going on with this. So, anyways, let's go ahead and figure out how to actually do this. If you have to do this because your teacher enjoys torturing you. If we want to find out what x and y are using Cramer's rule, we have to find out what the determinant of the matrix is first. So, in order to do that, we have to follow the steps. Step 1, cry. That's step 1. Step 2, after you dry your tears, we need to take the first few numbers out of there. Just the numbers 6, 2, 3, and include the signs. If there's a minus sign, it's a negative. Negative 8. Okay? And then we have to take the determinant of that matrix. This method involves doing the determinant like a million times, which is also kind of annoying because what even is a determinant, right? Like, really though, what is a determinant? Is it permanent? Is it in the firmament? Is it impertinent? I don't know. But if we want to find out what it is, we times these guys. So that would be 6 times 8. 6 times negative 8 to be exact. And then you have to minus the other ones being times. You have to remember to like change the signs and then times, and then there's already negatives involved, and yeah. So that's going to be negative 48. 6 times 8 is 48. 2 times 3 is 6. So that's going to come out to be negative 54, I believe. You can check me on that math if you want. Negative 54. So that would go in this little box right here. And the 6 and the 2 and the 3 and the 8. I would write, I mean, I can kind of write them in here in these little boxes. But, you know, it's kind of hard to see. But I'll write them anyways, because why not? Negative 8. Negative 54. Okay, cool. So that's the determinant. That's not even like halfway done. You're like 1/3 of the way, even less, but probably like 1/4, like a quarter of the way done already. I want to cry. All right, so we got the determinant. Step 3, cry some more. Step 4, we need to find some more determinants. We need to find the determinant of x this time. How do we do that? You kind of like find x by ignoring x. It's kind of weird. It's so it's like basically if I get rid of this and I ignore x by x, you should ignore your x anyways. There's a reason why they're your x, right? Okay, so 2, 1, negative 8, negative 8. You ignore the x column. The rest of the numbers make your x determinant matrix. Makes 0 sense, so just don't think about it, because the less you think about it, the more sense it makes. So 2 times negative 8. 2 times negative 8. And then we're going to minus. I'm going to run out of space, otherwise I'm going to like dip over to the area over there. So I'm going to go over here. Negative 8 times 1. Right? So crisscross. It's like top left to bottom right, and then you kind of circle around and go top right to bottom left. One way to think about it. All right, so what would that even be? That would be 2 times negative 8 is negative 16 minus, and then that would be a negative 8. So that's negative 16 plus 8 which is negative 8. So that is not what x is equal to, unfortunately. That is only what the determinant of x is equal to. This top part right here, they didn't really label. This is dx, or the determinant of x. In order to find x, you have to divide the determinant of x by the determinant, which is why this method is so convoluted. This method is determinants. It's ants that are determined. Okay, I have a list of words that sound like determinant over here because, dad jokes. All right, so d of x we found out was negative 8. D was in green. I don't know why I put it in blue. I should have put it in green. What am I doing over here? Such a peasant sometimes. All right, so D is green, which is negative 54. Okay, so then what is x? Well, it would be this simplified, right? Well, they're both negative, so, there's that. We can make them positive. We can also divide them both at least by 2 because they're both even. Half of 8 is 4. Half of 54 is 27. And I believe that's as far as we can go, which is interesting. Yeah, because, what else would you do, right? Okay, well, there's that. And last but not least, now we're like maybe half-ish of the way there. I know, crazy. Step 5. Cry some more. Step 6. We got to do the same thing for y. So this time we're ignoring y. And I have no idea why. Okay. I keep saying I'm going to stop, but then I keep going. Can't help it. Dad jokes for life. Okay, here we go. Ignoring y to create the y determinant matrix. Again, the less you think about it, the more this is going to make sense. That's a 6, a 1, a 3, and I get a negative 8. Crisscross. So that would be 6, negative 8, minus, and then that's going to be, hold on, I was distracted by something. I was thinking about what I said earlier. Because 4/27 is just a weird answer. Alright, I don't know, it feels like it should be not that answer. Negative 48, minus 3, negative 51. Whew, okay, so again, that's not what y is equal to. If only that was just dy. And if you want to know what y is, it's dy over the determinant. The determinant of y over the determinant. Wow. We are very determined here. Whew. Alright. I swear these jokes will be impermanent. Negative 51 over the determinant is negative 54, which we already found from earlier. And what is this going to be? Well, those numbers are pretty close. When numbers are pretty close, they normally don't divide by a lot. And these numbers are not going to divide by a lot. But they do both go into 3, and they're both negative. So if I divide that by 3, I believe that's 17. Maybe. And then this, divided by 3, should be 18, because it's 3 away from that. And that looks right. Maybe. I don't know. Could be right. You can always find out. You know how else you could find out? By literally any other way. Elimination, substitution, graphing, a matrix even. Even a matrix would be easier than this. You can actually set up one matrix, just the whole thing, put it in a matrix, and then do uh, the thing where you make like the ones and zeros. I forgot what that was called. The identity. There we go. And then that basically solves it, and you can make the calculator do it. So it's not like too terrible if you're using a graphing calculator. But anyways, literally anything else would be easier than this method. You could check it some other way if you want to, or you can just trust me that I got the right answer. It's up to you. All right. Well, that'll be it for this. Go ahead and check out my other stuff, myersmathematics.com, or email me, mr.myers@myersmathematics.com if you looking for tutoring or if you have a question about one of my courses. Toodaloo.